Welcome and hope you are going to enjoy what I'm going to share with you guys today. Remember to like and subscribe. Shall we begin? Thank you for watching.
You send one text message before you go to sleep. Check my emails, fix the failing tests in my project, and send me a morning brief. You wake up, and it's done. All of it, while you slept. Looking at this title slide, you are seeing the profile of OpenClaw. In just 4 months, it accumulated over 250,000 stars on GitHub, surpassing React to become the most starred open-source software project in the platform's history. Every AI tool you've likely used up until now has the exact same limitation. You type a prompt, the AI generates a text response, and then you have to do the actual work. You copy the draft, paste it into your email client, and click send. The AI described how to do a task. You executed it. This diagram illustrates the shift. On the left is the manual chatbot model. OpenClaw, on the right, executes the system calls to send the email, confirms the delivery, and schedules a follow-up automatically. The framework operates on 3 principles. First, it runs locally on your hardware. Second, it is model agnostic, meaning you plug in any large language model like Claude via API. Third, it lives natively inside messaging apps you already use, like Telegram. True utility comes from delegating labor to the machine, rather than simply generating better text answers. This timeline tracks the project's rapid growth. In November 2025, an Austrian developer named Peter Steinberger started a personal side project. 4 months later, it had eclipsed major startup products in developer adoption. He originally called it ClaudeBot, as a nod to Anthropic's AI model, Claude. After a trademark complaint, he leaned into the crustacean theme, briefly testing Moltbot before landing on the final name, OpenClaw. The impact caught the immediate attention of major tech leaders. NVIDIA CEO Jensen Huang noted that every company would soon need an OpenClaw strategy, comparing its importance to foundational technologies like Linux or HTML. To understand why it scales, we have to look at how it processes commands. A standard chatbot relies on a single direction loop. The human prompts, the AI responds, and the cycle immediately ends. This graphic breaks down the alternative, the agentic loop. OpenClaw takes your goal, perceives its environment, plans, executes on your real software, observes, and repeats. Because it constantly repeats, it maintains persistent memory, remembering preferences, and running scheduled background tasks. This slide outlines the 5 architectural principles that make the agent run. We've covered the local persistent memory, the proactive heartbeats, and the model-agnostic core. But a vital component is the multi-channel gateway. This funnels over 20 different platforms into a single inbox. You can text your agent a command from your phone via iMessage and pick up the exact same conversation later on your laptop via Slack. Looking at this grid of community use cases, you can see how flexible this setup is. Developers send fix failing tests via Telegram before bed. Families use shared agents to coordinate grocery lists. Analysts have the system autonomously build full HTML competitive reports. This flexibility relies on how easily OpenClaw learns new abilities. Everything beyond its base function is added via a skill. And a skill is simply a digital folder containing a basic text configuration file. The Markdown file defines the skill, while a JavaScript file handles implementation. You can build capabilities in 20 lines of code. This low barrier led to over 700 community skills. Your agent automatically searches ClawHub to install whatever tools it needs. The platform's strength comes from this open ecosystem, allowing it to infinitely acquire new capabilities to match your specific workflow. Look closely at this warning from the maintainers. Because OpenClaw executes real actions on your computer, it requires a strict technical baseline. If you do not know how to navigate a command line interface, this project is currently too dangerous to run safely. This ecosystem grid shows how the industry is addressing those risks. NVIDIA built NemoClaw to wrap the agent in enterprise-grade privacy guardrails, and the open-source community developed SecureClaw to run automated security audits based on established threat frameworks. These security measures emerged because major governments and state agencies immediately restricted its use. They are treating it as a highly capable piece of infrastructure, not a simple consumer application. This slide details the 4 steps to safely start. Install on your laptop, create separate accounts, plug in your AI model, and connect a messaging channel. Pay attention to the core rule. Security risk is strictly proportional to the access you grant. Take a look at the core tenet here. It executes, it does not describe. Before you write a single line of code or download a repository, you need to decide what specific manual task you are ready to hand over. Setting this up changes your role from an operator of software to a manager of an autonomous system.
Thank you for staying through the video. Subscribe to watch more AI-related content.